everyone. My name is Yomna Hamuda, and we're going to be learning about hypothesis testing today. So first, we're just going to see what's a hypothesis, some real-world examples, types of hypotheses, and the hypothesis test procedures. Here's our introduction. A hypothesis is an educated guess based on logical reasoning and data. A hypothesis is made when there is limited data or evidence to prove a point or thesis, and we make these hypotheses all the time in the real world. For example, during experiments, when we make theories for experiments, when we theorize on possible outcomes or anything that would come out of something that we suspect would be true or false, that's when we make a hypothesis in order to kind of come to a conclusion about an idea. Let's look at some real-world examples. We have health and medicine, which is here we have zinc tablets and length of colds. Hypothesis for this would be that zinc tablets reduce the length of colds by 1 day. Now this is something that you can test through a statistical test maybe. You also have another example here we could look at, make a hypothesis for education, note-taking on paper, and grade standards. So maybe we can make a hypothesis that taking notes on paper increases chances of scoring better on an exam. This is also something that we can test. So as you can see, hypothesis is something we can test, we can use in an experiment, and we can get outcomes out of. Let's look more at the calculations aspect. So what are significance levels? There are two types of errors. There's error 1 and then there's error 2. So the significance level alpha is the chance of rejecting a true null hypothesis. What this means is that this would be the highest probability that you would be able to commit a type 1 error or make a type 1 error. And for error 2, it's similar, it's just that it's instead of alpha, it's beta, and it would be the chance of not rejecting a false null hypothesis, meaning it would just be the kind of like the opposite of an error 1. Another thing we can look at is critical regions. A critical value separates the critical region from the non-critical region. You'll understand this a little bit better when we take a look at some examples. And the critical or rejection region consists of test values that indicate significant difference. So this is what would help you figure out if you should reject the null hypothesis, depending on where your critical value falls under, or your test value, I mean. The non-critical region is basically just the test, it says right here, the test values that suggest that the difference is more due to chance than anything else. So you would end up just concluding that your null hypothesis is not being rejected. A left-tailed test is when your mu is left-tailed like that. So it's kind of like a tail, but it would just be pointing to the left of whatever value you have. The right-tailed is the same thing, but the opposite. So your mu would be greater than your value. And for a two-tailed test, that's just when your mu is equal to your value. So for the left-tailed, it would mean that your area lies on the left side of the mean, and we say the mean is right here. And for right-tailed, it would be on the right side of this defined line. And for two tails, it would be not really different, but it would just be, you would just have two different lines right here, and your areas would be defined as like the opposite ends of these. A null hypothesis tells us in the statistical data set that there isn't any significance or differences, no significances or differences in our data set. And the alternative, it's an idea presented to show that the data will be different. Let's finally look at the test procedures. We're just going to go over it a little bit. So here's the procedure for hypothesis testing. What is the null hypothesis and claim? You basically just want to state the known value or the industry standard or whatever standard is being given in the question. Usually it will always be in the problem statement. And then see what that hypothesis is claiming. So is it saying that the value that we're trying to test for is more or less, or is it just like different, like just an alternative from the industry standard? And step 2 would be to find the critical values, and this can be done on the tables that, for just example's sake, you would do this by subtracting 1 minus alpha, which if you remember is our type 1 error, and then this would get us an area, and you would use this area to find a number on one of these values. For example, for 0.9901, which we have right here, we would just look to the left, see that it's 2.3, and then look to the top, see it's 0.03, and we would conclude that our z from this chart is 2.33. Seeing what is our tested z-value. So after we find the area under the curve using alpha, which we already mentioned was 1 minus alpha, this is going to give you a calculable z-value, and then you're able to solve for a different z-value. I know the wording is a little bit off here, but you would solve for a tested z-value using this equation right here. Make your decision here, draw a picture of the curve, which would usually look like this. Label our z-values. You always want to draw a picture. You never want to do any of these without drawing a picture of your curve. And finally, you just say, what's your conclusion? This is where you can summarize your results. You make a formal statement saying if your null hypothesis can be rejected, accepted, if there's not enough information. And now we're going to finally look at our examples. So we're going to start by stating the hypotheses, which is h naught would be mu is less than or equal to 10 minutes, as shown here. Always include your labels. And for the second hypothesis, your mu would have to be greater than 10 minutes, which is what it was talking about. Next, you would find your critical value at alpha equals 0.01. Your z would be 2.33. Of course, you should do this on your own. And then for number 3, you want to compute the test value. So you're going to just look at the values right here. We have 11 minutes. So 11 minus 10 minutes, 10, over the standard deviation, which you can see is 3 over 50 customers. So that's square root 50. And that is going to be equal to approximately 2.36. Because z equals 2.36 is greater than 2.33, we would reject the null hypothesis. Fifth step, our conclusion would just be that there is enough evidence to suggest the average waiting time is greater than 10 minutes. And that's all for this problem. So you already know what to do. We can say h naught mu is equal to 5. And then we can say that h1 is mu is greater than 5. You can say that the critical value for a right-tailed, because you can see it's right-tailed, test is alpha is equal to 0.5, or sorry, not is, but at alpha is t equals 1.729. And then now that we have this value, the critical value, we can compute the test value. So it would be pretty much like, almost like an identical sort of equation. So 6 minus 5 over 1.5 over square root 20, which will give us 2.985. Please do this on your own. And so we can now make our decision. We would reject the null. There's enough evidence to support the claim that the program helps participants to lose more than 5 pounds. So the answer for this would just be that for our first step hypotheses, mu is equal to 12 because the average height is 12 inches. And then h1 is mu is greater than 12 because the average height is greater than 12 inches. This is our t equals 1.711. Please use your t tables for this. And for 3, same equation as last time. The more you practice it, the more muscle memory it becomes. So it's 13 minus 12. And 2 over square root of 25. And that should give you 2.5. And then here you can make your decision. T equals 2.5, which is greater than 1.711. So you would reject, and once again, we have enough evidence. You can write this out to support the claim. In conclusion, the decision to reject or fail to reject the null hypothesis depends on comparing the test statistics to the critical value or the p-value to a, just in symbolic terms, and the failure to reject the null hypothesis does not prove that it's true. It just simply indicates insufficient evidence to support the alternative hypothesis, and context matters. A significant result is not only a statistical conclusion, but also a practical one, depending on whatever application that it's being used for. And hypothesis testing overall can just help us understand how valid our ideas and theories are, and they help us with real-world applications, as long as we just do them using experimentation and analysis, and for the sake of numbers. And that is all for hypothesis testing. Thank you for listening to this.